Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. Now we are going to see deterministic finite automata. Okay, so from the name only we can say that it is going to be deterministic. Okay, why it is having the name deterministic means from one state. By getting one input alphabet, it will go only to one state. That's why it is called a deterministic. Means if you are having, if they have given you some state, this is the state. Now by getting A, input alphabet A, it should go only to one state. That's why it's a deterministic. So Q0 by getting A, it is going to Q1 only. Q0 by getting A, it should not go to any other state. Only one state. So by getting one input alphabet from one state, it will go only to one state. That's why its name is deterministic finite automata. Okay, because it is deterministic that if from that state, if that state will get some input A, then it will go to only that state only. Okay. Now see, a deterministic finite acceptor or DFA is defined by the quintuple. So it is defined by quintuple consists of 5 tuples. It means this quintuple means consists of 5 tuples. Okay. So M is your Q sigma delta Q0 F. Okay. So it consists of these 5 tuples Q sigma delta Q0 and F. So what is Q? Finite. So it is always going to finite and non-empty set of states. Always finite and non-empty set of states. So Q is finite, non-empty set of states. What is sigma? Finite, non-empty set of symbols. It is even going to be finite. It is even going to be non-empty. See, Q is finite, non-empty set of states. Okay, now sigma, finite, non-empty set of symbols called input alphabet. Now what is delta? Delta is your transition function, that is Q cross sigma goes to Q, means from one state. This is going to represent Q is finite non-empty set of states. So that means state that by Q0 by getting A, where it is going Q1. So this is the transition function that Q0 by getting A, where it is going Q1. Okay, see, it's going only one state, Q only. So from going to only in one of the state means one of the states in Q. Okay, so Q cross sigma goes to Q is a total function. It's called the total function, called the transition function. So because of that only, it is having a from one state it is going to only one state. Because our delta is saying that from one state by getting one input alphabet it is going to one state only. Okay, and Q0 belongs to Q is the initial state. Here Q0 is the initial state. So here we are representing initial state by getting Q0. And F is a state and it is going to be a subset of Q is the state of final state. So F is a state of final state belongs to Q, that capital Q. See the difference between Q and F. Initial state is only going to be one. See, Q belongs to Q is the initial, but F is a state. So final state can be more than one. So final state can be more than one. So even if it is having one, then also it's fine. But it can be more than one. Now see the example. So this is a machine I have taken. This is the delta, that is a transition diagram. See, the transition delta we can represent by using two ways. One, by transition diagram, or by using transition function. The transition function is even called as transition table. Okay, so that we will see how to represent. So this is a machine. So this machine here initial state is A. So Q0 is A. What is capital Q? Set of all state, non-empty set of states A, B and C. The capital A, capital B, capital C is the Q. What is your input alphabet? A, B, C, A, B. So by A, capital A by getting it is going to B. Capital A by getting it is going to C. C by getting A, it's going to C. C by getting B, it's again going to C. B by getting A, it's going A. B by getting B, it's again going to B. Okay, what is the final state? So here, final state is only one, but it is going to be state. So it is going to B. And this is your transition diagram. See, one state by getting one input alphabet, it is going to only one state. And in case of DFA, for every state we have to give transition for every input alphabet. For every state we have to give transition for every input alphabet. Here input alphabet is AB. See, this state by getting it is going to be even I have to give the transition for B. This state by getting B, where it is going? This state by getting B, it's going to state C. Okay, so in DFA, for every state we have to give transition for every input alphabet. So for every state we have to give transition for every input alphabet. Okay, and since it is a deterministic, so this you have seen the transition diagram. Now see the transition table, or that is even called as transition function. So in transition table, here we are going to write the states. Okay, so states here is A, B, C. So we will write A, B, C. Final state is B. So final state we have to give a star, and initial state is A. So we have to give an arrow. Okay. And input alphabet you have to write here. Here input alphabet is A and B. So A on getting A, where it is going? B. A on getting B, where it is going? C. B on getting A, where it is going? B. B on getting B, where it is going? B. C on getting A, going C, B. So this is a transition table. Or it is even called as transition function. So we can represent the data by using either transition table or transition diagram. So both are equivalent. So in GATE exam they generally ask whether these two are equivalent or not. Yes, these two are equivalent. You can represent the DFA either by using the transition diagram or by transition table. So this is going to show us that one state by getting that in one input where it is going. Now see extended transition function. Transition function we have seen. Now it is extended transition. And this term is very important because it is even asked in your GATE 2017. Okay. So what is extended transition function? It is denoted by delta star. So if your delta, this is your transition function. Delta star is your extended transition function. So delta will say you that one state by getting some input where you are going. One state by getting one input where you are going, let us assume Q1. Now again delta Q1 by getting B where you are going, Q2. Okay, and what is delta star? Delta star is one state by getting string where it is going. Delta is one state by getting input alphabet where it is going. Delta star is one state by getting the string, like string AB. So Q0 by getting it is going to Q1. Now Q1 by getting B where it is going, Q2. So Q0 by getting AB where it is going, Q2. So this is your delta star. Now see the definition. It is convenient to introduce the extended transition function delta star. So which is saying that Q cross sigma star. It is a string. Okay. So one state by getting string, it is going to some state. This is your means the formula. The second argument, this is the second argument of the delta star is a string rather than a single symbol. Okay, it is not a single symbol, it is a string. And its values give the state the automaton will be in after reading the string. So this is going to give a result that this automaton will be in the which state after reading the string. Now see, this example we have taken. See delta Q0 by getting it is going to Q1 and Q1 by getting B it is going to Q2. So this is the delta. Now extended transition function Q0 by getting AB, Q0 by getting AB where it is going. So Q0 by getting it is going Q1, then Q1 by getting B it is going to Q2. So this is the extended transition function. Now how to formally define that? So formally we define delta star recursively by delta star Q any state by getting null string, that is your epsilon, is going to same state. So every state by getting empty string is going to same state. And now extended transition function of QWA, this is now a string. So how to do? Now first you have to find the extended transition function of QW. So first you have to find the extended transition function of QW where it is going. So Q by getting W where it is going. Then you find only the transition function. You will get some state. That state by getting A where you are going. Okay, this is the formal definition. Now see an example. And this is applicable for all Q, for all W and for all A. Okay. Now see delta star of Q0 AB. So first I have to find the extended transition function of Q0A, delta star Q0A. See, first I need to find the delta star on Q0A. See. Then the state where I have reached. So I am finding delta star Q0A. So first, then after reaching that, that's for that input P. Okay. Now see delta star Q0A. How we can do? Now see here, nothing is there. So what I will do? I will assume as a epsilon empty. So delta star Q0 epsilon empty. Now comma A. After reaching this state, we need to find the delta of that state, that input for that input. So delta on A. So first find the extended transition function on before that the last symbol. So extended transition function before the last symbol is nothing, that is the empty. Okay, so Q0 and empty, where it will go after reaching that state, we need to find the transition function on the last input alphabet A. So you know that it is going to give you Q0 only. So Q0, you will get here Q0, then A. So Q0A, where it is going? Q0A is going to Q1. See. So here extended transition function of Q0A, you are getting Q1. So by seeing 1 and 2, see, by seeing 1 and 2 Q0AB, here you will replace Q1 then B. So Q1 B is going to Q2. See, this is the formal definition I have explained. But simply you can do like this. Q0A is going Q1, Q2. It will save your time. Just for the sake of the syllabus, I am explaining that. But it is easy, straightforward. Just do that one. Now see a question, how to construct a DFA and minimal DFA. Okay, so what is the main difference between DFA and minimal DFA? See, from the name only you can say that the minimal DFA means it is going to contain minimum number of states in DFA. Okay, see, for a language you can have more than one DFA. For a language you can have more than one DFA. You can construct more than one DFA. But there will be only one minimal DFA. But there will be only one minimal DFA. So for a language there is going to be only one minimal DFA. So that's why even in GATE exam they are interested in finding the minimal DFA, not the DFA, because otherwise the answer will vary. For different student the answer is going to vary. So that's why they are asking the minimal DFA. Okay, I will explain you here how minimal DFA and DFA. Now see, so it is saying that construct a minimal DFA which accepts set of all string starting with A. Now it is saying in minimal DFA. First I will construct a DFA, set of all string starting with B. So it will accept. So we have to construct a minimal DFA that will accept set of all string starting with B. Means the language, and over the sigma A comma B means the strings will be from this only AB. Now B is a string starting with B, BA, BB, BAB. All these strings are starting with B. But A, it's not starting with B. AA, AB, not starting with B. So whenever we are constructing a DFA, we have to take care that it should accept only the string that belongs to this language. And it should reject the string that not belongs to this language. Okay, so these are the strings belongs to that language, it should accept it, and the strings not belongs to that language should get rejected. So if this is a machine, by getting B, I am going there. I am accepting because B belongs to this language. Now again, if I am getting other A, again I have to accept it because in the beginning I got B. After that, whatever will come, I have to accept it. Now after that, if again I am getting B, I have to accept it. Okay. Now see, I have told you in DFA for every state we have to give transition for every input alphabet. This state by getting B it's going there, but this state by getting A where it is going, I haven't given the transition, so I have to give a transition. So this state by getting A I need to give a transition, and I am going to a dead state. Why? Because it has started with A, so there is no chance it will ever get accepted. So it is never going to belong to this language. So dead state, it is even called as trap state. Okay, means you get stuck here because you are never going to now satisfy the condition that this language is same. Okay, so after that, whatever you are getting, you will be there only. So after, if you are getting A, be there only. If you are getting B, be there only. See, this I am giving in comma. It means by getting A also, by getting B also. Okay, this is the step by getting A also here. So you can give the transition in comma if in a same, so like here a comma b. Okay, now after here also by getting anything you will be in final state because it will get accepted. So since you have started with B, after getting anything it will be accepted. Okay, because it belongs to this. Now see, this is a DFA but not the minimal DFA, because you can reduce the number of states in this DFA. How you can reduce? By only getting B you are accepting. Now after that whatever will come you can accept now. Why you are creating another final state? Just be there only. Just be there only and give a loop of a comma b. This is a minimal DFA. You can't reduce the number of states less than this. So minimal number of states you require is 3. And in GATE exam, in numerical ability type questions now, they are asking as a NAT. Okay. So what will be the minimum? What will be the number of states you will require for this kind of languages? Okay. So when you can say that this is a DFA for this language, now I will stick to minimal DFA because you understood the difference between minimal. So minimal DFA is also a DFA, but when a DFA is containing the least number of DFA, means you can't reduce the number of states further, then that DFA is a minimal DFA. Now here we have to consider two things. When we can say that for this language this is a DFA, when all these strings belongs to this language should get accepted and all these strings not belongs to this language should get rejected. So B, BB, BA, all these things, A rejected, AB rejected. Okay. So this is called as acceptability of a language. I will write the definition later. Okay. Now when we can say that a string is getting accepted. Okay. When we can say that a string belongs to that language when a string is accepted. Okay. So upon scanning the string from the initial state, if it will reach any of the final state, okay, see, we can have more than one final state. So if we are scanning the string from the initial state, let us assume that the name of this state is Q0 and Q1 is. Okay, so I am having the input ABA. Now upon scanning the string from the initial state, Q0 by getting A where it is going, Q1. Now Q1 by getting B where it is going, Q1 only. Now Q1 by getting A where it is going, Q1. So upon scanning the string from initial state, if it reach any of the final state, then we can say that that string is accepted. But if it will go in non-final state, this is our non-final state. This is the final state. If it will reach non-final state, halt or stop is same. Okay. If it will reach and stop or halt in non-final state, then it is rejected. Okay. So what is acceptability of a string? Upon scanning the string from the initial state, if it reach any of the final state, then we can say that that string is accepted. So this is acceptability of a string. And when we can say that for this language this is a DFA, see, for this language we can even, someone can even say me that sir, this is also a DFA, minimal DFA for this. Now see, this is not a minimal DFA for this language. Why? Because set of all string that are starting with B, it is getting accepted, but also the set of all string not starting with B like A, epsilon, AB, A, it's also getting accepted, but our minimal DFA should reject that. So that's why it is not a minimal DFA. Okay. So we have to see both. The string that belongs to that language should get accepted like this, and the strings not belongs to that language should get rejected. Now see the definition. That whatever I have told you I have written so that you can write in your notebook. Okay. So acceptability of a string by DFA. When you can say that a string is accepted by that DFA. Upon scanning the entire string, if we reach a final state from initial state, then we can say that that string is accepted. Now since there can be more than one final state, and if at least we are able to reach any one of the final state from initial state, then we can say that string is accepted. Now see, acceptability of a language by DFA means when we can say that for this language this is a DFA. Okay. So a DFA is said to accept a language if all these strings in the language are accepted. See, I am saying all these strings belongs to that language should get accepted, and all these strings not belongs to in the language are rejected. And for this only you are going to get many questions in your GATE exam. What they will do, they will give you a question and they will give you the language, or 4 DFAs they will give, and they will ask you which DFA is for the language, or they will give you one DFA and they will give you 4 options that which is a appropriate language for this DFA, and it will look very similar. Okay. So you have to do elimination method, that whether the string that belongs to that language whether that DFA is accepting or not. Okay, so this is very important, because in GATE exam it seems that all the 4 options are correct,